Today we will continue the second part of the logic gates. Last class we have seen the basic logic gates, AND gate, OR gate and NOT gate. Today we will see rest of the gates. So first one is the NAND gate. Though logic circuits of any complexity can be realized by using only three basic gates, AND, OR and NOT, there are two universal gates, NAND and NOR. These NAND and NOR gates are called universal gates, each of which can also realize logic circuits single-handedly, because you can realize all other Boolean expression and gates using these two NAND and NOR gates. That is why they are called universal gates. The NAND and NOR gates are therefore called universal building blocks. Both NAND and NOR gates can perform all three basic logic functions, which are AND, OR and NOT. Therefore, AOI logic means AND or invert logic can be converted to NAND logic or NOR logic. Okay. NAND means if you separate this term, NAND means not AND. That means the AND output which is inverted, right, or noted. So, a NAND gate is a combination of an AND gate and a NOT gate. Okay. So, this is the logic symbol of your NAND gate. These are the logic symbols of your NAND gate. So, different input combinations have been applied. Okay. Now, NAND gate means not AND. So, you can also express a NAND gate as this is an AND gate, two input AND gate. Now, we have to invert it, right? So, now at the output of this AND gate, you put a NOT gate. So, it will become a NAND gate. Okay. So, if A and B are two inputs, the output of this NAND gate will be AB whole bar. AB is my AND gate. Since it is NAND means not AND, so AB whole bar. So with two input NAND gate, four input combinations are possible, 0, 0, 0, 1, 1, 0, 1, 1. So it will be, output will be completely complementary to the AND output. 0, 0, if you do the AND operation, it is 0. But since it is NAND, it will be 1. 0, 1, 0. Complement 1. 1, 0, 0. Complement 1. 1, 1, 1. Complement 0. This is the truth table of the NAND gate. Now, we will see the 3-input NAND gate. 3 input means ABC. There will be 3 variables and X is the output. So, output will be ABC whole bar. So, we have for a 3 variable input, 3 input NAND gate, we can have 8 possible combination and we will be having the corresponding output. So, 0, 0, 0 is 0. Since it is NAND, we have to take the complement 1. Likewise, we will get the output. This is the truth table of a 3-input NAND gate. Now, coming to the NOR gate. NOR means not OR. That means the OR output which is noted. So, a NOR gate is a combination of an OR gate and a NOR gate. In fact, NOR is a combination of the OR word, not OR. Okay. So, the output expression of the NOR gate, we can write X equals to A plus B plus C plus whole bar. Okay. Whole bar. This is the basic symbol of your NOR gate. That means not OR. This is my OR gate, right? So output will be A plus B. We have to put an NOT gate here. So output will be A plus B whole bar. This is the logic symbol of your NOR gate. So that means not OR. 0 plus 0 is 0. So that is the OR output. But what will be the NOR output? 1. Just a complementary of your OR output. 0 plus 1 will be 0. 1 plus 0 plus 1 is 1. Right? We have to take the complement. So it is 0. 1 0 NOR will be 0, 1 1 NOR will be 0. This is the truth table of the NOR gate. Now this is your 3 input NOR gate. So ABC are 3 input. This is the logic symbol. X will be A plus B plus C whole bar. We have all 8 combinations are there. 0 plus 0 plus 0, 0, 0 bar is 1. Likewise, we have to find the output for all the 8 possible inputs. Now, NAND and NOR are the universal gates. Now, we will see the exclusive OR gate or XOR gate. A XOR gate is a 2 input 1 output logic circuit whose output assumes a logic 1 state when one and only one of its 2 inputs assumes a logic 1 state. Under the conditions when both the inputs assume the logic 0 state or when both the inputs assume the logic 1 state, the output assumes the logic 0 state. Since an XOR gate produces an output 1 only when inputs are not equal to 1, it is called an anti-coincidence gate or inequality detector. The output of an XOR gate is the modulo sum of its 2 inputs. The name exclusive OR is derived from the fact that its output is a 1 only when exclusively one of its inputs is 1. It excludes the condition when both the inputs are 1. So how it is happening? This is the logic symbol of the XOR gate. So for a 2 input XOR gate, we can have 4 possible input combinations 0 0 0 1 1 0 1 1. So how we will find the output? When both of my input are same, output will be 0. When the inputs are different, output will be 1. See, 0 0 same input, output will be 0. 0 1 different input, output will be 1. 1 0 different input, output will be 1. 1 1 same input, output will be 0. Okay. So these are the logic symbols of different input conditions. We can write general form X equals to A XOR B. Okay. Now the XNOR gate. It is the exact complementary of the XOR gate. Okay. So an XNOR gate is a combination of a XOR gate and a NOT gate. The XNOR gate is a 2 input 1 output logic circuit whose output assumes a 1 state only when both the inputs assume a 0 state or when both the inputs assume a 1 state. The output assumes a 0 state when one of the inputs assumes a 0 state and the other a 1 state. It is also called a coincidence gate because its output is 1. Only when its inputs coincide, it can be used as an equality detector because its outputs are 1 only when its input are equals to 1. So, this is the expression of a 2 input XNOR gate. X equals to A NOR B, X NOR B equals to AB plus A bar B bar. That means A XOR B whole bar. Because A XOR B, how can we simplify A B bar plus A bar B? Since XNOR gate is a complementary of XOR gate, so this is the expression for XOR. We have to simply put a bar symbol here. Okay, and these are the truth table of the XNOR gate. So in XOR gate, what we have seen, when my inputs are same, output will be 0. And when the inputs are different, output will be 1. So here, exact opposite condition we have to consider. When the inputs are same, output will be 1. When inputs are different, output will be 0. Okay. So this is the general expression X equals to A NOR B. Now, if we find the logical equivalent of the following expression, A XOR 0. A XOR B means A B bar plus A bar B. A dot 0 bar plus A bar dot 0. 0 bar means 1 and A bar will be A bar. So this is how we can simplify. A XOR 1. A dot 1 bar plus a bar dot 1. A XNOR 0 means a bar dot b bar plus ab. A bar dot 0 bar plus a dot 0. A XNOR 1. A bar dot 1 bar plus a dot 1. 1 XOR a bar. A b bar plus a bar b. 1 dot a bar bar plus 1 bar dot a bar. 0 XOR a bar means 0 dot a bar bar plus 0 bar dot a bar. Okay. Now, let's consider one example. Show that a plus b into ab whole bar is equivalent to a XOR b. Okay, and we have to construct the corresponding logic diagrams also. So a XOR b, first write the truth table of a XOR b. If we can prove both the truth tables are matching, then we can prove that this expression is equals to this expression a XOR b. We already know the truth table of a XOR b. When the inputs are same, output will be 0. When the inputs are different, output will be 1. And AB, just write the 4 input combinations and a plus b, because we have to simplify this expression. A plus b will be 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. Then AB we have to find out. That means we have to multiply A and B. Write it here. Then we have to find out the AB complement. If it is 0, it will be 1. If it is 0, it will be 1. If it is 1, it will be 0. Then we have to multiply these A plus B into AB whole bar. This is coming as 0, 1, 1, 0, which is nothing but your XOR truth table. So we can prove this way that this expression is this expression. A XOR B, we already know this is the logic symbol of A XOR B. Okay, and how we will implement it? A plus B, this is the NOR gate, right? This is the A plus B, this is the OR gate, right? This is the OR gate, and this is your AND gate. So A plus B, but we need AB whole bar. So we have to invert it. We will put a NOT gate here. So AB whole bar plus A plus B. This we have to AND it. So we will put an AND gate here. Okay. Now let's see another example. Show that AB plus A plus B whole bar is equivalent to A XNOR B. We know the truth table of XNOR B. So when inputs are same, output will be 1. When inputs are different, output will be 0. Now we have to write the truth table or simplify this expression. A, B, write the 4 input combinations. Then A plus B we have to perform. We know 0 plus 0, 0, 0 plus 1, 1. Likewise, we have to write the A plus B. Then AB, A and B, we have to do the AND operation. Then A plus B whole bar, we already have found out A plus B, so we have to find the complementary of it. 0 will be 1, 1 will be 0, like that. Now we have to perform a OR operation. So AB, this AB, we have to OR it with A plus B whole bar. 0 plus 1, 1, 0, 0, 0, 0, 0, 0 and 1, 0 will be 1. And we know this is the logic symbol of your XNOR gate. So this is the OR gate. We have to get A plus B whole bar. So we have to put an inverter here, a NOT gate here. So this is A plus B whole bar plus AB. This is the AND gate. So we have to perform an OR operation between this first term and second term. So just put an OR gate here. So we will get the final logic expression.